Okay, thanks for being here at, I don't know, the end of days, the end of the last day of the conference. Hopefully, maybe we can just let loose and have fun. So I'm gonna talk about something that is, you know what? First, I'm gonna talk about me. My name is James Blair. I founded the Zuul project. I am one of the maintainers, primary contributor to Zuul. I started a company called Acme Gating to focus on Zuul full time and help companies use Zuul effectively. That's how I'm able to eat and contribute to the Zuul project, which are two things that I love to do. Zuul was originally started for the OpenStack project, of course, and then it got used by BMW and then other people, and now it's used by a large number of organizations with various requirements. So really quickly about Zuul, like this isn't a Zuul introduction talk, but I'm going to highlight a couple of things that are going to kind of come around later. So why are people interested in using Zuul? Why should you use Zuul? It is a Git-driven system. So it is, in fact, if you're here for the previous talk, you heard how sometimes it can be a little frustrating that it's a Git-driven system. But we really adopted the idea that before GitOps was even a thing, like Git drives our development, it drives the operations. Everything should be done in Git. All of the configuration should be done in Git. That sort of thing. Zuul allows a lot of flexibility for folks setting up CI and CD systems in terms of centralized and decentralized control. It offers this thing called project gating, which I'll get into in a minute, with speculative execution. It facilitates cross-project collaboration, and it's very scalable. So to talk about a couple of these things in a little more depth, by being Git-driven, we want our code and our infrastructure changes to be tested and deployed together, which is actually a big reason why we're doing this thing with Nodepool. This ability to have central or local control of your CI/CD system is a big part of Zuul. You can dial that knob into either extreme if you want. You can define all of your processes centrally, or you could let your developers do whatever they want. Or you could do anything in between. So gating is, so this is sort of the way I think of the history of continuous integration. We started with the original idea of continuous integration is actually that you're testing the past. You merge a change, and then you run a test on it, and then you find out whether or not that change merged. That was like back when you go back to what Hudson was doing when they first adopted the term continuous integration. That's what that meant. Then after that, people said, "Hey, why don't we run the test before we merge the changes?" And we got this sort of pre-merge testing, which I think is testing the present. You're testing the change that you wrote. You're testing it right before it merges. So yeah, that's testing the code. Zuul does a neat thing. It tests the future. It tests the change as it is going to be when it is merged, which is a subtle but really important distinction. And once you start thinking that way, there's actually a whole lot of things that follow out from that. But this is the central idea of gating: is that every change that is proposed is tested as it is going to be merged before it merges. So let's get on to what Nodepool and Zuul is about. So within Zuul, any with any CI system, you need to run the job somewhere. And within Zuul, we designed it to run those jobs on ephemeral test nodes. So originally these were VMs inside of OpenStack clouds. Because of that history, obviously this came from OpenStack. But we've expanded that to include AWS, Google Compute, Azure, IBM Cloud, as well as Kubernetes and OpenShift test resources and static nodes. This is how we, these are where all of Zuul's test resources can come from. The component of Zuul that is responsible for getting those test resources and providing them to the jobs in Zuul is called Nodepool. And what Nodepool has two components to it, a launcher and a builder. The Nodepool launcher launches these virtual machines in clouds or creates the pods in Kubernetes and that sort of thing. And then the builder is responsible for building VM images. So this way you can have Nodepool builder build images with exactly the configuration that you need for testing. Maybe it has some things cached on it. It has the all the build tools that you need. You can build these images, and then when you launch the VMs, you launch from those images, and your jobs are ready to go sooner. And this talk is about why we're killing Nodepool. So Nodepool is it is the oldest. I wonder if I have a slide about this. Yeah, I do. So I will see that. Just a real quick aside about the builder. The way the builder operates is that it runs a program called Disk Image Builder, which again came from the OpenStack world. That's a whole way of building images, and then the Nodepool builder uploads to the cloud. This new thing that we're doing will be able to use Disk Image Builder. So if you're using Nodepool Builder now, it's going to be an easy transition for you. But there are other options available for building images that you'll be able to use in the future. So why did we create the Nodepool Builder in the first place? It is the oldest component of Zuul. It predates Zuul. It was originally, when the idea of Zuul itself was still a Jenkins job, Nodepool existed. And in fact, before Nodepool existed, Nodepool was a Jenkins job too, because I don't know, there must be some law of computing that everything can be reduced to a Jenkins job. That's where all of this stuff came from. So originally, we had a Jenkins job that would build and upload an image, and then our Jenkins jobs that then caused virtual machines to be launched from those images and added to Jenkins as worker nodes could use them, right? So that's how this started. It turns out clouds are unreliable. Maybe. It has been said that clouds may be unreliable. Let's go with that. And so doing this in a job was a little problematic. So we created our first daemon to do any of this stuff, which was the Nodepool builder, to kind of run these long-running image build jobs, and then supervise the uploading to clouds and retry if it fails and things like that. Some of the code that's in Nodepool today, like you can trace it directly back to this. It's reached the end of its usefulness. So it's kind of time to move on and do something else. So one of the things that we wanted to do with this is improve the image management process. So in Nodepool, you do things with a bunch of configuration files, and then those get updated on disk, and the daemons read them. And right, like it's very Unixy, but it's not very Zuul-y. Because remember I said we want all of the configuration to be in Git. We want to be able to do speculative testing and things like that. So we want to move the configuration of all of this stuff into Zuul. And we want to make the image build process more visible. So as fate would have it, we're going to go back to having jobs to build images. But we're not just having jobs to build and upload images. We're going to have jobs to build the images, which improves the accessibility of the images, the image build process to users, right? Because they can go look at a job. But we're still going to keep the daemon to upload the images to clouds, which is unreliable and users don't need to see that, right? So we've swung from having everything's in jobs to everything in the daemon to now we're actually putting the right thing in a job and then the right thing in the daemon. So I think that's going to give us the reliability that we need and the visibility. So the first question I get when I say, hey, we're going to do this. We're going to move these images around, like, well, how do you, if you have a Nodepool builder, that's a long-running process. The image build process itself can use caching and things like that. So we did this in OpenDev. We build images that cache all of the OpenDev repos on them. And we don't, every time we want to build an image, we don't want to clone everything from Garrett again. That would cause a denial of service attack. Besides, our Garrett server is too busy handling all of the AI crawlers. It doesn't have time for things like the CI system. So we had this cache on the Nodepool builder so that we didn't have to do all this cloning every time. Well, so the neat trick about this is that this is kind of a snake eating its tail thing. Once you create the first image using the new Zuul image building framework, you then have an image with your cache on it. And so the next time you build an image, what you do is you run that job on a node that was launched from that image, and that image provides your cache. So your cache that you built becomes the cache that you use for the next image build. So it's a pretty simple solution to that problem, as long as you just adjust your thinking to realize that it's this continuous cycle. So yeah, the first one's going to be different. After that, it'll be fun. Another improvement that we wanted to make is we wanted images. We wanted to improve the testing of images, because with Nodepool Builder, you make a change. You wait a day for that image to get built and then deployed, and then all of the jobs fail after that. We wanted to, so because the image builds are going to be in their own Zuul jobs in the future, like they're just regular build jobs. If you propose a change to how an image is built and that change is wrong, and it fails, then you're going to see that job fail. That image build job should be part of your gating pipeline, so it shouldn't even merge. We're walking the walk finally on not merging broken code when it comes to image builds. So image uploads. So this is the stuff that is still as a daemon. This process is more complicated, right? Like we couldn't make everything simpler. This one gets a little more complicated, but I think it's worth it, and there are some things that we can do to improve it. First is at the end of this image build job, you've just built an image on an ephemeral node. We're not, and we don't want to upload it to the cloud from that node. What do we do with it? Well, you have to stash that image in a temporary space. So at the end of the build job, put it in Swift or S3 or some object storage system, right? Then what's going to happen after the completion of that job is the Zuul launcher will download the image to its local space and then upload it to whichever clouds need it. So for example, in OpenDev's case, we're going to build an image, we're going to shove it in Swift somewhere, the launcher is going to download it and upload it to the, well, we have 6 clouds and even more regions. So, I don't know, like 9, 13 different endpoints it's going to upload that to. That's what's going to happen in OpenDev because that's the environment that we're in. Some folks are going to be lucky enough to have an environment where they can, where their temporary location for the image can actually be the permanent location. So, for example, AWS is one of these environments. So you can stick the image into S3 and it will be directly imported from S3 as an AMI, so that you can skip those steps. So maybe Glance will let us do some neat things with that someday. But we have so many clouds that we deal with in OpenDev. It's going to be a heterogeneous environment anyway. So we're always going to be doing some downloading and uploading. So as I mentioned, all of this configuration for images is that's configured as Zuul jobs, but also switching over to the idea of the Nodepool launcher, where we're launching nodes in clouds. The configuration for these resource providers is also going to be in Zuul's configuration language. So that will be much more user serviceable. Users will be able to make changes to it directly. Right now, because that configuration is sort of centrally managed, it's pretty much always going to be something that the CI team is doing because you could accept contributions from users to that configuration, but it's the CI team that has to review and merge those because that is central configuration. With Nodepool and Zuul, as we move the stuff into Zuul, that little dial that I had earlier, that becomes available to you. So you can continue to do everything centrally if you want, or you can totally trust that your developers will responsibly use the power to launch an infinite number of test resources on AWS. Or you could limit them. You can set max, right? But I'm sure they'll do the right thing there. But yeah, whichever is wherever you want to set that dial, you'll be able to do that. There are a couple of new concepts in the Zuul launcher. These all map to new top-level Zuul configuration objects. So right now, if you're using Zuul, you're defining jobs and pipelines and semaphores and things like that. In the future, you'll also be defining images and flavors and labels and sections and providers, because that's what we needed to do to get all of the flexibility that we need. So I can go through a few of these really quickly. This is what an image looks like. Turns out it's really small. The idea of defining an image in Zuul is essentially reserving it as a name in the namespace. So that's why you don't need to do much there. So in some repository somewhere, somebody has said, I'm defining an image called Debian Bullseye. That's going to be a Zuul managed image as compared to a cloud image, right? So you can still do the thing where you can just use the upstream cloud image if you want. But at any rate, this is where this image name exists, and then once it exists, other things can start referring to it, like job. So this is all it takes to turn a regular Zuul job into an image build job. All you need to do is say image build name, and then the name of the image, and then you've told Zuul, oh, well, if you ever need a Debian Bullseye image for a provider, this is the job you need to run to build it. And so later on, when you start adding images to providers, Zuul will say, oh, hey, somebody said there should be a Debian Bullseye image in this provider. It's missing. I need to run this job to build it. So there's a bunch of new triggers for how image build jobs get run. They can get run because they're missing. They could get run in a periodic pipeline, so that you rebuild them every day. They could get run because a change merged in the gate pipeline. So any way you can think to run a Zuul job, you can run an image build job And then once you've told Zuul that this image build job exists, then that's how Zuul knows to do the new management of that image. Flavors are just the generic concept of flavors or instance types or whatever the cloud wants to call it, right? So you can say that we know we're going to be running resources of different sizes, so I'm going to go ahead and spec some out here. And then we have a concept called a label, and this should be familiar to you because Zuul was already using labels when it talks to Nodepool. So like today, when you define a Zuul job, you say I want a node of a certain type, you're saying I want a node with this label, and Zuul asks Nodepool for a node with that label. So what we're doing is we're bringing that concept into Zuul itself, and we're saying there is now a concept of a label called Debian Bullseye 4 GB, and label is a combination of an image and a flavor. So you can see what we do there. We just kind of matrix out the permutations there for whatever ones that you want to be able to support. So we had to make up something completely new. So in Nodepool, we have a thing called a provider, right? It kind of looks like this, right? But in Zuul, because of the way that we're doing the configuration, we needed to be able to say, we need to be able to support this idea of doing some things centrally and some things out on the edges in individual repositories. So we had to split up the idea of a provider. And so what we did is we created this idea of a section, because frankly, like, we wrapped our brains on this. We could not think of what a part of a cloud is. Like, we were trying to come up with there is no cool word for part of a cloud that I'm aware of. If you come up with one, please let me know. It's not too late to change, but at any rate, a section is a part of a cloud, right? So oftentimes that's going to map to a region. But we didn't want to call it a region because not all clouds have regions, and you might not actually want to divide it up that way. But basically, it's a part of the cloud. It's probably a region, and so as an example here, but it also supports inheritance, right? So this specific example is an abstract section which refers to the entire Rackspace Flex cloud. You would then probably have another section that inherited from it, and then that was so this section is the full cloud, and then you could section that section into having the DFW region of the Rackspace Flex cloud, that sort of thing. And then once you've sectioned things however you want, and you can attach flavors and images to sections in a very similar way to the way that you do in Nodepool today. But once you have the sections all done, then you define a provider. That's the actual thing that's going to be responsible for launching and accounting for the nodes and everything. And that's where you want to, generally where you're going to want to put your labels. So this will be the SJC3 main section of the RackFlex SJC3 section. So, sorry, the RackFlex SJC3 main provider, which is attached to the RackFlex SJC3 section, and it has these 3 different labels available on it. So that's a really quick high-level view of what the configuration looks like. So the Zuul launcher, this is the daemon that is replacing all of Nodepool. So it's a new Zuul service. In addition to all of these new behavior changes, there's actually a lot of changes that we're making on the back end, because in addition to like the motivations here were not only the visibility and the maintainability and accessibility things that I mentioned earlier, but also the Nodepool launchers are they're not able to kill clouds at the rate that they used to be able to. it's a little sad. We used to we've taken pride in the public clouds that we've taken offline due to the throughput from Zuul Launcher, but frankly, it's not cutting it anymore. It's not fast enough. It's not mean enough. So the Zuul Launcher has a number of performance improvements. Zuul launchers are cooperative. Nodepool launchers are standalone. In fact, a lot of people don't know this or willingly disregard it, but you're not actually supposed to run more than one Zuul launcher for a single provider. They have no idea what they're doing. They will fight each other if they're not configured right. If they are configured right and really smart, you can do it. But they're not designed that way. Zuul launchers are cooperative. They will, you can horizontally scale the number of requests that you're sending to your cloud provider by horizontally scaling the Zuul launcher system. You can also limit it, like there's rate limitings, so you can dial it down once you succeed at taking your cloud offline and lower it to an acceptable point. They also do something, and I've been working with the BMW folks on this. They've actually done a lot of these contributions in terms of the design and the implementation. And I want to shout out to them for the rendezvous hashing. That was particularly clever, I think. That way we can actually have all of these launchers. They choose which requests to handle and which nodes they're going to handle using rendezvous hashing, so that they cooperatively decide how they're going to distribute their work without talking to each other. So we've actually a lot of things in Zuul we actually have to sort of mutex through Zookeeper to decide like who's going to run what job and that sort of thing. The Zuul launchers don't talk to each other to decide that. They just know what requests they're going to do. So multiple launchers can be working on supplying nodes to a single request at the same time. Related to that, one of the big shortcomings in Nodepool was that a Nodepool, only a single Nodepool provider could handle a Nodepool request. But with Zuul Launcher, requests can be filled by heterogeneous providers. So you can finally request a Kubernetes pod and an OpenStack virtual machine for the same job. So real quick summary here. The whole idea here is that we've got new techniques for self-service and resource management and improved throughput for high volume cloud use. Again, hopefully scaling Zuul up even more. So I've kind of been using this mixture of past and future tense when I'm talking about Nodepool and Zuul. What's going on here? This work is very close to completion, but still in progress. In a minute, I'm gonna make some suggestions about like how and when you get started and stuff like that. But let's also talk about the transition. How do we move from Nodepool to Nodepool and Zuul, or Zuul Launcher? We realize that's going to be a big concern for a lot of people. Everyone, like even in OpenDev, where sometimes we can play fast and loose with some things, we had to deal with this very carefully. The two can cohabitate. So you can continue to run Nodepool as much as you want, and then you can start up a Zuul launcher and run them in parallel. You can sort of switch between the systems one label at a time if you want. Basically, if a label is available to Zuul, if a Zuul label is available to Zuul, it will prefer that, otherwise it will fall back to Nodepool. In fact, if you're running Zuul 13 right now you are falling back to Nodepool. The way that we've been developing this is in the main line of development, but behind feature flags and a lack of documentation, which is not not always the way that we do things, but I think we needed to do it for this one because what we need to do is we need OpenDev to find the big issues first, and we need the flexibility to be able to pivot on major decisions without the rest of the community needing to keep up with that. So we're trying to we're trying to have OpenDev be at the vanguard of this and find these issues first, work things out, and then then we want the rest of the community to start helping us test. But we want that to be really smooth transition. So like I said, a lot of this stuff is in the mainline of Zuul right now. Please don't use it yet. But this is how this is the mechanism that we're using to sort of alpha test it before we ask other people to beta test it. And so to that end, OpenDev has not run Nodepool for 3 months now. So we did do a gradual transition. We changed over one label at a time, and we finished that up about 3 months ago. And things have been working fairly reliably. And I proudly showed this off to somebody earlier, and there was a stuck Nodepool request, stuck Zuul launcher request, and I don't know why it's not deleted, so I have to go figure that out. But one stuck request that nobody noticed is we're getting to a pretty acceptable level of flex there. Having said that, we're still at a stage where a couple of weeks ago I made a major change to the configuration syntax. I've got one more major change up for review, and that's the really big thing that's the main reason why I'm asking people don't run it yet, because by keeping this small, we can make these major changes quickly, and because we're not making them with backwards compatibility in mind, which we wanted to keep in the future. So if you were to try to run this today, you'd have to make sure to read every commit very carefully and understand what you needed to do manually to do the upgrades. It's not where we want, but we're getting really close to that. We're finishing up the static driver, and then there's a couple of more important drivers like Kubernetes. We want to get in there. But the key thing here is the static driver. That's the last one that I anticipate where we might need to change major aspects of this, right? Because that's the last one where we introduce a new concept that we need to make sure that we modeled correctly. Once we're happy with that, it's kind of like bring over the rest of the drivers, finish the documentation, and then we'll put out a call to hopefully all of you to start testing this. And the transition can be this can take a while. I don't know that we've agreed on or promised how long we're going to keep the Nodepool backwards compatibility there, but if it were a year, that wouldn't surprise me. I think there's going to be plenty of time for people to make that transition. And I mean, it obviously would be longer to stay on the older version. So thanks for your patience through this process, because I know a lot of people are eager to run it, and I am eager for other people to run it and have tests. So I think we're going to get there very soon. So if you want to learn, I mean, you probably know all this, but here's some websites where you can learn more about Zuul. The documentation for all the Nodepool and stuff will be up there eventually. And if you want to learn more about me and how I can help you, aggregating, that's our website there. I think that was maybe only a little bit long, but we're at the end of the day and there's nobody trying to kick us out. So that's it. I can take questions.